Hello and welcome to the next video. In this video, we are going to discuss a new type of the supervised machine learning. The first we have discussed about the classification, and now today we are going to discuss about the regression. So before starting the regression, let's recover the basics that we have already discussed or in our previous video. So firstly we have discussed the classification. Firstly we have just understand the basics of the machine learning, like how many types of machine learning are. The first one was the supervised machine learning, and then other was the unsupervised machine learning, and then the reinforcement machine learning. And then our the next video, we had discussed about the classification, and then about the types of the classification. Especially we had discussed about the decision tree and the naive based classifier. And now today we are going to discuss about the next topic, that is about to the regression. So as we already learned about, the regression is also the supervised machine learning type. So what actually the regression is, it's a technique for investigating the relationship between the independent variables or a features and a dependent variable or a outcome. So we already have discussed all these things, like what actually the features are, what actually the dependent or independent variables are. So the regression is just a relationship between the independent variable and the dependent variable. The independent variables are like the we have a column, the feature like the x values in simple wording, and the dependent variable the y value or the target or the outcome value. So how many types of the regressions are, uh, why we use the regression? So these are the different techniques, I mean different categories that exist in the world, uh, to to uh, to represent the regression, like the predict the prices of anything. Suppose we want to predict the price of the house, or we want to calculate the interest rate, and the measure the blood pressure as per the age, and the salary. So these are all the regression problems. And suppose, just for instance, we have a house and we want to calculate the price of the house. And suppose we there is a employee who is working, and we want to predict the salary of that employee because of his experience and because of his skill, right? So these all things are related to the regression problems, regression machine learnings. And suppose here is the just basics diagram. Suppose the y and x, and then we have some points to the going to the x and going to the y. So suppose here, and then like here the plus symbol, then a plus, and then plus, and the dot. And then after that we just draw a line uh, to predict the things. So dependent variable and independent variables whose value wants to forecast, I mean the forecast the y, our predict value, the variable that explain the others. Meaning that the x value, I mean the feature value, are those that we want to use to predict the forecast or predict the future. In machine learning there is a some one term, the forecast. Actually this is not in the machine learning, it is a general term. The forecast means that to predict the future things. So here it goes to the like this way. So there are some types of the regression. The first one is a simple linear regression. In the simple linear regression, we have only one independent variable and one dependent variable, right? And in the multilinear regression, more than one independent variable and one dependent variable. In the logistic regression, one or more independent variable or to predict the one uh, from a target variable. So this is seems like a bit confused. So what does the meaning of simple linear regression? Suppose we want to calculate the price of a house, right? And suppose we want to calculate the price of house as per their square feet, right? So the square feet is the one variable, I mean the one independent variable that works to calculate the price for the dependent variable, I mean the y value, right? So this is for the simple linear regression. And what actually the linear regression equation is, how to calculate the linear regression. The basic the formula of this one is a y is equal to a plus bx. Actually this is not a ab, it is actually y is equal to alpha plus beta x. So what actually the when we calculate when we use that formula in a machine learning, we will use most likely a b, or you can use any kind of variable over it. It's not like a b or x y. This is just general term, so you guys can use with your own variables. Like you can use a x, and I mean the y is equal to s plus bx, or might be you can use a m plus bx m y. All the it totally depend on you. And y is a dependent variable, and a is the intercept or a constant value, the value of y when x is a 0. So what does this mean? So when we are going to draw a line from here to onward, the starting point of our x and y is called a intercept, I mean the starting point of the uh, line. And when we draw the line, suppose our some points are goes to I have actually the another image here. So suppose we have a x, it goes to the from 0 point to 100, 200 and 300. And then on the y side we have a 10, 15, 20, 25 and 30. And here the starting point from the x and y is the a value, I mean this value, and then the b and x. And here when we come to like this one, suppose we at the point of we draw the line from here, and in the case of 10y, the 0 x is a suppose a 0, and we draw some kind of dot here. Let me actually draw something for you here. Suppose we have some value like this, right? X and y, and we have some point here, we have some point here, we have some point here, and we have some point here. Might be we have some point here, or might be we have some point here, or some value here, and some value here, and some value here. When we draw a line like that, so you can see that some points uh, are are on the line, I mean that is the best fit, but some are from the away from the line, like this one. So when we draw a line that like that, or when we draw a line like that, when we draw a line like that, and it is working the same way. There are some points, and when we draw a line, so the points are away from the regression line. Like the as I said, this is a simple linear regression, like one variable and one independent variable and one dependent variable. So over here, uh, like these are the one point but have some gap to fit the line and also here there is a line, here is a line, but here is a point. Might be it could be your price of anything, or it could be your any continuous value, right? Or the number value. So this is the line is away from this point, is away from this line, and also this point is away from this line. And what is this, why these lines are from away from, I mean why this point is away from this our line? Because there is some kind of error. So what does this mean? The error is a least square. We simply just called it uh, mean square error. uh, just consider in this way, mean square error. And the formula for the mean square error is a MSE is equal to 1 over n, and the sigma or the sum of n I is equal to 1, and then yi minus y naught and I, and then the square of this y minus I, or and y minus naught minus y naught I. So this is a simple formula that we mostly use in our math, like a plus b, right? And then the square of this, or sometimes we use a minus b and the square. So this is the same formula when we I mean again simplify this formula, so it goes to the a plus b plus a square plus b square plus 2ab, like that. So it works the same way. So this is the when we simplify the formula, so it comes like this mean square error. So it comes over here, y minus mx 1 plus b, and square plus y2 minus all that. So it works in this way. So what we have learned so far, the regression is a technique to investigating the relationship between the independent variable and the dependent variable. So what are the independent variable? These all are actually the continuous values. That values is changing toward, changing to the times. So this is the about the regression problems. And also to calculate the things like how the our models are predicting, and what actually the actual value, and what was the original value, and what was the other value. So for that we have to use a what was the actual prediction, and how our model is predicting, is our model is predicting the accurate, or is our model is predicting the something wrong. So for that we have to use some different approaches. uh, there are the least square method, and in over here also there is some two common the terms, like the first one, a cost function and the gradient descents. So in the cost function, a cost function is a measure of how wrong the model is in the term of its ability to estimate the relationship between the x and y. As over here, the x is our value, and the y is our called it a target variable. So this is the same. The cost function is measure of how wrong the model is in the term of its ability to estimate the relationship between x and y. Typically, it represents the distance between the predicted value and the actual value. Like over here, our model predicted this point, but the actual value is something like here, and the same like in the top and on the bottom through the line. And when we make a slope for this one, that will be our actual error message. So when we come over here again, typically it represents the distance between the predicted value and the actual value. The cost, function loss or error can be estimated by looping, repeating iteratively through running the model to compare the estimated prediction against ground truth and the known value for the y. So this term is a bit confusing for everyone, like if because I did not explain everything, like how the point is working over here and how the point is working over here. But in our when we start working with our with the models, so we will see that exactly how our model is working and where it is throwing the some kind of error, and what is the error terms are, right? And when we calculate everything, suppose this was the formula. When we do error over here to estimate the y is equal to a plus bx plus e error term. And the another thing is the gradient descent. it helps the model to minimize the cost function. Like we have, the cost function is a measure of how model is predicting the wrong value. The descent helps the model to minimize the cost function. Gradient descent enable a model to learn the prediction or gradient that it should reduce the error. Error are the difference between the actual and the predicted value. So this is about the basics of the regression. It sound like a bit complicated, but it is not. In our next video we will try to read a data set and try to cover the mean square error and also the cost function and how we use the cost function and all that with the appropriate machine learning model. And thank you for watching.